A quick introduction to this product that comes from Red Hat called Sofware Collections. It's also rebuilt by a few of the Red Hat rebuilders. So anybody who's been a sysadmin or had to deploy applications written in Python or dynamic languages or will probably have run into an issue where the system packages aren't what you want for your application. One of the things that comes along with that is, like, if you're on RHEL 5, which is actually not EOL'd until 2017, so you'll get security updates and you're fine to run it, except it ships with Python 2.4, so, and a bunch of other ancient things. So if you have your application running on there and it needs like Python 2.6 plus, then there's really it's not really easy to upgrade. You can kind of build Python yourself, and then if you make it the system Python, then you're going to affect your system tools like Yum. What you'd probably end up doing is like building or getting the updated Python that you want somehow, and then putting it in op somewhere and doing virtual env or like some kind of environment hackery like that. And the same goes for other languages as well. Conversely, you might need to run legacy apps, so you're kind of stuck on like RHEL 4 forever, and you can't really upgrade, and the path to do that is just too tricky, and then if you do it, then you're going to have to hack some stuff together, or you're just going to leave it and not upgrade at all, and then the OS is EOL and you're not getting security updates, and that's like a really terrible situation. So Sofware Collections is not the first thing that's come along to try to solve this problem, but it's a way, and it's integrated with Red Hat and its clones. It's a way to install multiple versions of software on the same system. You install them in parallel. You don't affect the system tools. You can install older, newer, or just different versions, things compiled differently or whatever. And you can build them for different releases. So you can have your same Python 2.7 application running on RHEL 5, 6, and 7, or yeah. So the terminology surrounding this product / framework is a little bit confusing. Sofware Collections is a framework. It includes some utilities. It started in Fedora, and it's been released in RHEL 5 and 6. It's a little bit like alternative, or like SEL Alternatives. I mean, it's probably the least like SEL Alternatives because you're kind of relying on symlinks and stuff like that. But there's a thing out there called modules. There's virtual env for Python, RVM. There's a thing called UPS UPD that's used at Fermilab. It's like 15 or 20 years old. Basically, the last three examples just kind of have scripts to sort of hack on your environment and change your path, your LD library path, and your path to sort of put you in another environment that's parallel with the system. So originally, Red Hat released a product called Developer Toolset, which had some newer versions of GCC and GDB and stuff like that. And to use those newer versions, you had to, they were offered as Sofware Collections, so you had to use the Sofware Collections utilities. Developer Toolset 1 was rebuilt for Scientific Linux. We rebuilt it. 2.0 was released a little more recently. It has some even newer GCC and stuff like that. Also, it has Eclipse. It hasn't yet been built for Scientific Linux, just because of some difficulties that we've run into with building Eclipse and some of the build requires that come from the Java stuff that comes from Fedora, and just figuring all that stuff out. But so it may be released in the future. But bottom line is, all this stuff uses the Sofware Collections framework to install and work with multiple versions of the stuff on your system. So then, in addition to Developer Toolset, Sofware Collections, or Red Hat released basically a channel called Sofware Collections, and they sort of packaged all of this together as Sofware Collections 1.0, and it includes these dynamic languages and databases, whereas the Developer Toolset is kind of more your compiler toolchain stuff. Here you'll get updated Python, Ruby, Postgres, and there's no JS in there, and these are all offered as Sofware Collections. So basically, a software collection, or to make a software collection, it's an RPM packaging technique. similar to some of the other ways you would use to do this. You install the software outside the system directories in this kind of tree. Opt provider, which will be from the things coming from Upstream, it'll be opt RH for Red Hat, and then the name of the software collection. And then under there, you'll have a file called enable, which is basically, if you look at it, it's a script that's just basically exporting all your environment variables to set up your environment, similar to like when you do activate this in virtual env. And then there's a root directory, which kind of contains a virtual, file system tree, like with all your user and your lib and all that stuff. So if you want to use this, so I'm going to talk about using it in Scientific Linux. It'll be slightly different in the other rebuilds and in RHEL itself. So what you're going to need from Scientific Linux is we've packaged a repo package, which I'm actually not going to risk doing this, like waiting for all the packages to download and stuff, but let's see. So I can send the link afterwards, but so we basically have just packaged a package that contains just the definition of the repo, because you'll have to install an additional repo to use the software collections. So I'll just look at, so that actually, if I rpm ls yum conf, so you're just installing that repo file, which if I cat it, it's just defining the repository, which we have kind of set aside from the rest of Scientific Linux. So if I want to do, this is going to be really long, but I'm going to disable all my repos, but then enable. So you can see kind of some of the stuff that's in there. You've got your Ruby 193, and then it's got all the dependencies and stuff that are part of that software collection. Python 2.7, your Postgres, and your PHP 5.4, and all this updated stuff. So if I wanted to use Python, I would do. So it's like just the name of a normal package, but usually has the version at the end of it. So this has been already installed. So that's how I would install my software collection. Okay, and so the way you work with the software collections is you use this utility called SEL, and it doesn't have too many options. If I do, this is, by the way, it's a VM, it's a Scientific Linux 6.4 VM, I think. So right now, the only software collection I've installed is Python 3.3. So, sorry. So, an additional argument you can give to SEL is enable, which basically runs or sources the enable file that gets installed when you install the package. And so then you do SEL enable, you specify the package, and then you put your command that you want to run. So whereas if I just run Python, my system Python is 266 on here. When I do SEL enable and I enable software collection, and then the command I want to run is Python-B, so then I get Python 3.3.2, which is the software collection Python. So probably a more useful way to do this would be to do SEL enable Python 3.3 and then run, start a shell. So we can kind of look at what enabling the environment did there if we look at our path. So now we see the first thing in our path is to opt. I mentioned RH is the name of the provider, Python 3.3 is the software collection, and then root is the root of your sort of virtual file system, and your stuff is defined in there. And then similarly, if it also messes with your LD library path. So that's how that works.
Why does it do that?
Because, I mean, it's just got its own, like if,
explain what the LD library path is. If you're...
Okay, so so when programs are compiled against libraries, shared libraries, they need to be able to specify what those, like what requirements they have. So one of the ways to manage, like you can do the system-wide with like ld.conf or whatever it is, and ld.so.conf or whatever, but then in your environment, you can add sort of a search path, the same way you do with your path that you look for binaries, but it's for your shared libraries, and that's controlled with this LD library path variable. So
Does
that's.
everyone know what path is? I don't know.
Does everybody know what that means? So, yeah, the path environment variable is a list of paths on the file system through which you're going to search to find. So if I just run like ls, I mean that is actually a file that exists somewhere in the file system, because when I just run ls with no arguments, like we're going to since there's nothing in the no, that doesn't work. So so it's basically, we need to find where the executable I'm looking for is located. So one of the ways that you do this is you search through your path environment variable, which has a list of paths that you'll search, and it'll find the first match and it'll run that one. So a way to know if I run the command which ls, it'll return the path to the executable that I would run on the command line if I just typed ls. If that makes any sense. Okay. All right, so yeah. Okay, this is like automatically going, so. Okay, so another thing we can sort of look at is we can go into opt rh Python 3.3, and I sort of mentioned there's this enable script, which is SEL enable is basically sourcing this. It's got all these environment variables that will control where you're going to get these executables from and libraries. And then if I go into root, there's basically like, you can't see it, but trust me, it's like basically just like what you would have at the root of your file system. It's not like trooted or anything, but it sort of fills in the environment that this software collection is going to care about.
The system tools require a different version, I thought, or may require a different version, but if it's in the path, it's always going to find this particular version under opt rh Python 3.3.
Only after you run SEL enable. So anything that you want, if you have your own application, you have some kind of bootstrap script that runs it, you're going to want to, well, there's a couple ways you could actually do it. You could build it as part of the software collection and have it kind of inside the environment as well. Or you could just you could have shell scripts that start your application that source that environment first and then run the stuff.
Enable under
Yeah.
user
Yeah.
environment and variables. Okay.
Yeah.
Okay.
Yeah. So, okay.
It's like dot profile or something, just set a bunch of variables or something, to find different paths.
Yeah, so I'll just go to there. So, okay, so, just to demonstrate. So, obviously, so if I'm going to write a Python script, I can't put, the full path, the literal path to my system Python in the interpreter line anymore. Like you might be used to just putting like user bin Python. You're going to have to use, if anything, which,
I can't read that.
Yeah.
okay.
Step back under.
Oh, God.
BG equals dark.
Set what? BG
Yep.
equals dark? Okay,
There we go.
thanks. Okay, so you're gonna have to do that. And then, okay, so, let's just do this. So, that was a Python. That's not going to work in Python 3 because print is like a function, and you call it like a function in Python 3. So if I do enable Python 3.3 bash, I'm going to get invalid syntax. So you can say I just ran the script, in my bash that had the environment that I sourced by doing SEL enable, and I'm in Python 3 now, and that fails. So. Okay. All right. So collections are built, you can install a package. So as I sort of mentioned, to use the software collections, you need this package called SEL Utils. I think usually when you install a software collection, SEL Utils will be a dependency. But if you want to build your own software collections, then you're going to need SEL Utils build, which actually just gives you like a bunch of macros. I won't go into too much about how the SEL packages actually work, but they basically make a meta package that has a runtime package that, sort of makes the skeleton of your dir structure and writes that enable script. And then there's like an actual build package. So there is a script that comes from Fedora called spec2sel, which is like, it's like a huge Python thing that just sort of tries to convert a normal spec file to a software collection spec file, which you can sort of use. I had a little bit of success doing this, but it's you definitely have to like tweak things. But if you want to build your own software collections, or you want to make your applications as part of an existing software collection so that it runs within that Python 3.3 environment, for instance, then you probably can get away with using the spec2sel, but you'll probably have to make some additional changes to your spec file. So some of the things that you could like just come to mind for me when I think about how you'd use this, you might want to. So MariaDB is out, and it's basically a drop-in replacement for MySQL. But as it stands now, you kind of have to choose. And if you're thinking about ditching MySQL and going to MariaDB, software collections could be a way to run both in parallel. And basically, you get two init scripts. So you just specify which one you're going to start. So you can try out your application on one, and then on MySQL, and then you can enable the MariaDB 5.5 environment and try it out there, and that'd be a way to test. One thing that we've sort of experimented with at work is if anybody has RHEL 5 systems still hanging around, Puppet 3 doesn't run on Ruby 1.8. So if you want to run the Puppet 3 client on RHEL 5, you could potentially use software collections to do this. You don't have to do this with Enterprise because they actually give you your own little encapsulated Ruby that's independent of the system Ruby, and I imagine they probably do it in a similar way to this. But my coworker had some success building Puppet 3 as a Ruby 1.9.3 software collection and running it that way on RHEL 5. And just the basic, you can upgrade those old. Like I've worked in places where it's been really, we've been really reticent to upgrade ancient app servers that are running old code, but this would potentially be a way to, to upgrade that app server and just take everything along with it as in the software collection. And maybe it could be used as an alternative to virtualenv. I don't know. It could at least be a really easy way to install, like when you instantiate a virtualenv, if you want to do a Python 3 virtualenv on like a RHEL 6 system or SL6. There's obviously lots of different ways to do it, but a really easy way would be to install the Python 3.3 software collection and then instantiate a virtualenv with that opt.rh Python 3.3 user bin Python. It's really convenient. Like when you think about the maintainability of, it's a nice RPM, it's packaged from Upstream for you, and all this stuff. So. And a couple just extra little things. And RHEL decided to just get rid of MySQL in 5.10. So, and they provide 5.1 and 5.5 as software collections. It's just that's sort of a heads up. And for that reason, when they did that, they made SEL Utils available in RHEL 5. So the way Scientific Linux works is a little different. I sort of talked about it when I spoke about Scientific Linux, but next week, SEL Utils will be in all of SL5. Right now, it's just in 5.10. So I have some links that are pretty small, but if you want to go to the presentation and download the presentation and look at it. There's lots of really good doc out there. It seems like a lot of it right now is mostly coming from Red Hat. Like I haven't seen like a lot of practical examples out there yet, but this was only, like Software Collections 1.0 was only released in September, and we rebuilt it in October. So it's still a pretty new thing, and it's kind of interesting to see what might come out of it. And that's it. I don't know if anyone has any questions.
Yeah. Like, is there other equivalent competing tools that do this?
There are. there's that thing modules, which I've actually never used, which basically messes with your environment so you can use different GCCs and stuff.
SEL is a lot better than our modules. We actually have the same problem in our HPC grid at work.
Uh-huh.
And we use a little bit of all from our homegrown one.
So this is kind of it seems like this is kind of like a combination of that modules tool and like it's also built in it like packet distributed as like a package.
Yeah, yeah.
Okay.
So it's, yeah, I mean, probably the main advantage over something else would be that you're actually getting a package that's nicely, like you don't have to build Python 3 yourself and then put it somewhere and opt and all this stuff, or get some package from someone else. It's coming from Upstream.
It's a little better than a PPA then too, because you can have it simultaneously, like a Ubuntu PPA where it installs.
I think your original question of is there anything else?
Mhm.
No.
Well, that does all of it,
Yeah,
but,
you can build your own thing.
and I've seen lots of examples of just homegrown stuff that just, sets your environment and then does it that way, you know what I mean? And then there's virtual env, which is, yeah.
But virtual env in no way would replace this, right? I mean, because this does binary.
Yeah, you would still need, yeah, I mean, yeah, it's similar in the way, it doesn't replace this, no, but it does the same kind of thing when you're using it, because it, yeah, you know
Seems
what I
like
mean?
this might replace virtual env.
Yeah.
Yeah,
Yeah.
possibly.
that's what- Do you run into problems with like missing dependencies, or are the packages great?
Well, the packages, oh, yeah, the question was whether there are problems with missing dependencies or if the packages are complete. You mean like the software collections packages themselves?
Yeah, so
Everything is pretty encapsulated, so like so the RPMs that come from Upstream those are going to be pretty much those are going to be nicely packaged, and basically all the dependencies of the package have to come along with it. We haven't had too many problems building the software collections packages, but you can run into, we have run into problems where you try to convert an existing RPM to a software collections RPM, because if the build requires aren't right in that original RPM, then you're going to be chasing down all kinds of dependencies. But it's really just like if the build requires are right, then I don't know if that's your question or if
that
it's,
is my
yeah.
question. It's pretty similar actually to the build stuff that we do for building GNOME.
Yeah.
So it's the same kind of process.
Yeah.
I was just wondering, because that's like one of the big headaches of running stuff in that
Yeah.
kind of environment.
Definitely converting, the Puppet thing I know was kind of a nightmare, but that's just because whatever source RPM we had from Puppet was, the build requires weren't all there, so it just kept failing, and then you'd have to go chase down one, try it again, and that's kind of how it went, yeah.
Okay. So
Can it be used to run, say, Python 2.4 on Red Hat 6?
So it could, yes, but right now, the software collections that are coming from Red Hat are Python 2.7 and Python 3.3, and they say they're going to add more and more on an 18-month schedule. So I don't know if they're going to, so what they've kind of done is they've added stuff that's newer than the system stuff. So Python 2.7 is newer than what's on RHEL 5, and 3 is actually even newer than what's in RHEL 7, turns out. But I think adding some older stuff too will be really useful. It just, whether that stuff is still getting security updates and whether they're going to patch that, I don't know. It gets kind of iffy there. But if you wanted, you could build Python 2.4 yourself as a software collection.
Okay, so it's not only limited to all those software.
No, because you can. It's both a set of packages available from Red Hat, which are just that list that I showed you right now, but it's also a method to build RPMs yourself. So theoretically take a source RPM from some other source and convert it, which may or may not be really difficult. I don't know.
What is an RPM?
Sorry, an RPM is it's a package format, and also sort of it's a format of for packaging programs, and it's the one that Fedora uses and Red Hat and some other distributions as well. So it's similar to your Debian.deb pack.
Help to say it's a zip file with everything included.
Sort of.
Including where to put things once they've been unzipped.
Yeah, it's sort of an archive with a set of installation directives, I guess you could say,
for installing programs.
for installing programs.
yeah,
Yeah.
it's
Or
like
install it. For one.
these similar in any way to relocatable RPMs?
Well,
Repeat the question, what do you think?
are these similar to relocatable RPMs? I mean, everything is still pretty hard-coded, and you still have to be root and to install them, so, I mean, there's a sort of conceptual similarity in that you're kind of taking something and putting it elsewhere, but other than that, I think they're kind of different things. Okay?